All right, we're going to go ahead and look at the squeeze theorem. So the squeeze theorem does exactly that. It squeezes some functions together to help us find a limit. Okay, so it says if f of x is less than or equal to g of x is less than or equal to h of x. Okay, so when we're doing a squeeze theorem, the function that's in the middle, that's the one we're trying to evaluate. Okay, and if you look at this picture, do you guys see how g is squeezed in between h and f? So what they're saying is our y values for h of x are above all the y values for f of x. And then somewhere in between there is our function g. Okay. Typically we do this when we're trying to find the limit as x approaches a of the middle function g of x. We're trying to figure out what that is. However, it's not easy to calculate algebraically, so we're going to use other functions that we can calculate easily to go ahead and help find the limit of g of x. Okay, so what this is saying is if you look at the function h and the function f, you guys can see that as it approaches a from the left and the right, for both functions, they have a value of L. Okay, so if you can conclude that the top function and the bottom function approach the same value at a, and g is squeezed in between there, then you can also confirm that the limit as x approaches a of g of x will also equal L. Okay, so we're going to use this idea of a squeeze theorem. What I would say, you guys, for the squeeze theorem is it's typically used with sines and cosines. Okay, the reason sines and cosines is because we know we can squeeze sine and cosine in between two numbers for the most part. Okay, -1 to 1 is kind of where you can squeeze those together. So let's take a look at an example. Okay, show that the limit as x approaches 0 of x squared sine of 1 over x equals 0. So the first thing you guys would do is you try and plug in x approaches 0 right here. So you'd have 1 over 0. However, we know that's undefined. Okay, so we can't find that. So what we do is we use the squeeze theorem. And I'm telling you, the trig functions are kind of a hint to do that. Okay, they're kind of one hint. So what do we know about basic sine of x? I just told you guys. We could squeeze it in between -1 and 1. Okay, if I were to have, because this has come up in the past, 2 sine of x. Who could you guys squeeze 2 sine of x in between? This is just saying that we have a vertical stretch of 2. So instead of going to -1 and 1, we'd be going to -2 and 2. Okay, so you might have to change the outside limits a little bit, but for the most part, you guys can use your transformations to figure that out, or you could always graph the function. Okay. All right, so we have sine of 1 over x. Okay, that is a form of sine, and you can graph it on your calculator and confirm. But yes, this piece right here, you can squeeze it in between -1 and 1. So we start out with saying, I got sine of 1 over x, and it is in between -1 and 1. Okay. And one thing I would take note of, you guys, is it says show. It's telling me the answer that's equal to 0, and every time it says show, you have to prove it. So you got to write out all the steps. Okay, so we got to write a proof. You got to prove it. Okay, so we're going to squeeze that in between there. And now I'm like, okay, this is not the problem I was initially given. It was x squared sine of 1 over x. So I need to make it look the same. So I'm going to go ahead and multiply by x squared. So I have negative x squared less than or equal to x squared sine of 1 over x, and is less than or equal to x squared. Now that I have that part, I see that this is my original. Okay. However, it's asking us to evaluate the limit. So now what I'm going to do is take the limit of all three parts. So I'd have our limit as x approaches 0 of negative x squared, limit as x approaches 0 of x squared sine of 1 over x is less than or equal to my limit as x approaches 0 of x squared. Now here's the nice part, okay? We can't find the limit of the middle part. That's our confusing function that we're not sure. However, our endpoints, can I find the limit of those? Yes, I can. Okay, so what I would do is, well, if I plug in 0 here, I'd have 0 squared, which is 0. Negative 0 is nothing, so it's just 0. And then I would still have my middle part. Same thing here. If I evaluate this limit, 0 squared is 0. All right, so it's saying that my limit of the function I was given is in between 0 and 0. If I'm in between 0 and 0, guess what my middle limit has to be? It has to be 0. So then we can write our conclusion. Therefore, can you either write out therefore? This is a little symbol for therefore. Therefore, by the squeeze theorem, we can conclude that the limit as x approaches 0 of x squared sine of 1 over x is equal to 0. So there is our proof. Okay, so it's starting out, you guys pick the sine or cosine function and then figure out what you can put it in between. A lot of times with those sine functions, it's -1 to 1 or based on your transformations. And then from there, you just can manipulate it to look to become what you want it to be. Okay, I believe I have a picture on my next one. Yeah, so here is the pink one is the x squared sine of 1 over x. Okay, and what we did is we squished it in between x squared and negative x squared, because you could find the limit of those as you approach 0. So we calculated that, and then it led us to our conclusion. We got in between 0 and 0, so that means the whole thing as the limit of x approaches 0 of it will also equal 0. Okay, so that's visually what's happening. Let's go ahead and give this a try again. Show that the limit as x approaches 0 of x to the fourth cosine of 2 over x equals 0. Okay, you can graph your cosine function of 2 over x and confirm, but it is in between -1 and 1. So we're going to go ahead and start out with that. So we will have cosine of 2 over x, and I'm going to put that in between -1 and 1. And I'm like, okay, that's not the entire function. I have x to the fourth, so we multiply everybody by x to the fourth, keeping our inequality balanced. So I have negative x to the fourth less than or equal to x, I wrote x squared, I meant to write x to the fourth. X to the fourth cosine of 2 over x is less than or equal to x to the fourth. So now I have created the equation I was given, okay, or the function I was originally started with, and now I want to evaluate the limit. So I'm going to take the limit of each one. So I have my limit as x approaches 0 of negative x to the fourth. Rewriting the function I was given. And this is, you guys, just the steps to prove how to go through this. And now from here, I cannot find the limit of the middle function. However, the endpoints I can. So I plug it in, I actually find it. I would try and plug in 0. 0 to the fourth is 0. And so we don't have -0, so it's 0. And we have the limit as x approaches 0 of x to the fourth cosine of 2 over x. It's less than or equal to, and I evaluate the right-hand side, so I plug in 0. 0 to the fourth is still 0. So my actual limit, if I'm squished in between 0 and 0, I can conclude that the answer for this limit is also 0. Okay, so therefore, by the squeeze theorem, we can conclude that the limit as x approaches 0 of x to the fourth cosine of 2 over x is equal to 0. And you guys, all of this work is necessary to show that, okay? Because when I'm asking you to show it, I'm asking you to prove it, okay? So make sure you write out all those steps. But that is it for example 4 and our squeeze theorem.